Bhagyasri madam, you can start now. Bhagyasri madam, you are not audible. Madam, you are not audible.
Yes, you are audible, madam. Am I audible? Madam, you are not audible. Not audible, madam. Can I start? Today's our session on webinar on introduction of structure design software. So I'm Yash Patel. I'm presenting with this webinar. First of all, I would like to thank you, Bhagyasri madam, for the introduction. In today's our session, our content is an introduction of StatPro, history of StatPro. We are going to see how we can design a structure in a StatPro or which type of structure we can design on the StatPro. Type of structure we can design on StatPro, how we can generating model we can see practically on a StatPro software. Advantages of StatPro. Let's start with there is a lots of software available in the market for a structure designing like StatPro, StatPro V8, V8i version or StatPro Connect, ETAP, Tekla Structures, App 2000, SAFE, STRD or Midas. All these software are international software and used for structure design of various type of structure like underground water tank and high-rise building. You can say bridge, uh, every type of structure we can design on based on this type of software. But the StatPro is internationally used, and we can design the lots of multiple software interconnection with a one structure and design with a multiple code. So introduction of StatPro is what the StatPro is structure analysis and design program software. It includes a state-of-art user interface, visualization tool, and international design code. There is lots of code available for design in the StatPro. We can design the same model with the Indian code and the same model with the American code, or you can say British standard code. These are also advantages. We can check, and the research scholar can also use the software to compare the each model with the various type of code. Uh, in StatPro, we can design of concrete structure as well as steel structure. We can design a bridge, multi-story building. The StatPro is working on finite element method. With the help of finite element method, we can design critical to normal. Every structure we can design with it. uh, in StatPro, there it is a Bentley's application or Bentley software. You can say Bentley have a numbers of application which is interconnected with StatPro. When we can understand its user interface, I describe it more. What we are doing in school, we are using calculation with the manual method. After we admission in diploma or in college, we use the scientific calculator. After that, we are using the Excel sheets or Excel programming. What the ultimate goal behind the using calculator or any software is that we can reduce time, also automate our task is with smart way to doing some exercise speedy. So what we do in structure design, that we are doing the every beam and every column design, footing design for the diploma level. It is okay to with one beam and one column design, but in a practical field, there is a in one building there is a numbers of beam and numbers of column. If we are going to design every beam and every column in a single way, that one by one column and beam design, it is not possible, or it is too much time consuming. So what we have to do, we have to use the software. Okay, so history of StatPro. StatPro was originally developed by a research engineer and international Yobra Linda, a one of developer of StatPro, who started coding and made some software named StatPro. Later in 2005, Research Engineer Institute was bought by Bentley. Okay, that software was bought by Bentley System, and nowadays the Bentley structure system is one of the owner of a StatPro, and many series and many updates on the StatPro. Let's see the structure. A structure can be assembled of element. Let me start StatPro first. Just a second. Okay, till then it start. It is a big software that take time to start it. So at the time, why we have to use this software? There is a many software in the market available for a StatPro or for a structural design. But why StatPro? The StatPro user interface is very user friendly interface, and we can design the complex structure in an easy manner. Okay, it started. I just said. Is my screen visible? Let's start with a new model. I'm going to open the new file. Stamina. That node beam point connecting uh, element beam. What is no node is just a point. Let's start with creating a one beam. This is a coordinate system. Okay. The water coordinate system, the X, Y, and Z in plane. This is the our working plane. That as same as the AutoCAD, we have the plane that we in which we are working. So this is our working plane. In bottom of that, you can see the X, Y, and Z direction. In the same manner, we have to put value here in the X, Y, Z, and the node will be created here. So I am typing my first node is 0, 0, 0. Okay. So you can see that there is a node created and node uh, geometrical value is 0, 0, 0. I want another node at a 10-meter distance in the X level. So what I can do uh, in X, I write down at 10. You can see there is a 2 point. First one is at a 0, 0, 0, and the second one is 10, 0, 0. What it means, there is a distance between 2 points in the X direction is 10 meter. Okay, let me connect it with the beam, and I'm going to create a beam with the add beam connecting 2 points. Simply beam is connected. Okay, let's go to the slide. A structure can be okay. A frame element, a beam elements, two nodes. What it means that any beam has a two nodes, or two nodes can be connect. The element can connect to the element which is connected by two nodes. It's also called a beam. What is a plate? Plate is a simply rectangular or triangular which is which have a three or four nodes. Or what is solid? Solid means in 3D, if we can say the we have the plate of 4 by 4 and its height is also 4. That's what it is. A solid. A solid have a 4 to 8 nodes. Okay. Instead, a node joint, it has a number and XYZ coordinate. A beam become a member, it has a number and node its end. Okay. The type of structure we can design. There is a simply four types of structure: a truss, a plane, a space, or a floor. What you mean by truss? A truss, which is a form of geometry which is not containing bending moment. It's only take a axial load. Okay, a plane. What it means, it will be on x-axis or it will be on a, oh sorry, it will be on a xy axis, or it will be on a xy plane, or it will be on a xz plane or yz plane, in any of one. But what is the geometry is only in a 2D geometry, not at all 3D. Okay, a space, a 3D geometry which containing member in XY, YZ or ZY plane, in every plane, and we are doing a vertical analysis all, as well as a horizontal analysis. It can a space analysis. The both we are going to see practically in a statue of floor. What we do mean by a floor, that which is in an x-axis or xy axis. When we are designing the floor, there is a only vertical or horizontal member, but there is a, if the floor is in an xy plane, there is a no bending moment in a z. Okay, understand? Let's understand it practically. Adding the, okay, what we created the node in a xy plane inside. See, y is the upward direction, x is the horizontal direction. So what we do in xy plane, we are generated the one beam which are two nodes. Okay, what we do in our SA1, SA2 or DSS, design of steel structure, that we are designing the one beam. The example is given like that, there is some load acting on our beam, and find out that how much shear force and bending moment will be there. But let's find that for a simply supported beam. Okay, I first of all introduce with this interface structure, statue interface. What is the first menu? There is a file. There's a lots of option. You can describe that title of project, the job name, client name. When we are going to generate a report, all this information will be the on header. Okay, so there is an engineer name, checker name with a date. Okay, after that the geometry. What do you mean by geometry? We are give the input to the software that how our structure will be, how long our will how long our beam will be, what is the floor height, our column, where is the tie, where on which member which load will be applied. We have to tell the computer or the software that what our problem is, and software give the result that for this problem or this much bending moment, this much shear force will be acting, or this member is fail under this load. Okay, so we have to give the software that this is what our geometry. So let's start with it. We are creating a node. For the node, we use what we use is a coordinate system XYZ and connected beam with it. See, here is the beam tab. In beam, there is we have the three option midpoint. If we connected the two members midpoint created, we can create with this perpendicular intersection curve beam. We can select insert a node between this point is also possible. Means there is an option with which we can create our geometry as fast as we can. Okay, after that there is a view tab. In view tab, if this is a small structure, okay, if there is 100 of nodes and 100 of beams, we have to see, or we have to work on different parts of the structure. So this view tab is also an important tab from the different top bottom view. Easily we can convert the view from it. Okay, if we want some special or some of the part of the member, some of the part of a whole geometry, we can work on that with a this select object view. Means what we select, only that will our visible, and we can easily work on it, a cascade window, or we if you want to do anything with the view, like you have to work on different view with the same time, you can do it here. There is also 3D rendering. You can see the how actually your in 3D your software will be look like, as we just created the geometry. We are not assigned the property yet. So in 3D view, just it shows just a line. Okay, this blue line containing what our member is, a 10-meter member with a 2 node. Let's give it a property. From geometry tab, beside it there is a property tab. Let's go into it. Here you can find a property section in which there is a define section. Okay, if you want to define its rectangular, circular, T-beam, or trapezoidal, general, tapered, assign profile, like you want to double angle it, anything. For the concrete structure, we have it with a 600 mm depth, 600 mm depth, and 300 mm width. Okay, I added section, added from which material? This section is from concrete material, so I selected a concrete and add it to the property section. You can see reference number 1, section 600 mm into 300 mm, its height rectangular, and its material is concrete. Now selecting the section and apply assign to selected beam. What it means, I selected this property and selected this beam and assign to selected beam, assign yes. Let's go to view, 3D rendering view. You can see that actual our model is here, that a high depth is a 600 mm and the width is a 300 mm. Okay, fine. And its total length is 10 meter. Okay, fine. What if we have to assign it a property like a steel section, which is an our IS code? So here is the option, selection database. Here it is. You can see, if we have to use, we have to design, and we are living in India, and we have to design for an American standard or some American company, or we don't know which section is available in America. So we can use the section tab and see what the American section is: W shape, M shape, S shape. There is a list of sections, same as the Australian section, Britain section, Canadian, Chinese. What we have to do right now is the Indian section. You can see S shape section, in which our ISMC is held, ISMB is held, or if we want to use channel section, here is channel section, angle section. All the section are available in this tab. That takes ISMB 600 at. I'm selected this section, this beam, and assign it. Say yes. See, a reference 2. Reference 2. Okay, let's see the 3D rendering view. Okay, you can see that there is the beam of 600 mm depth, ISMB 600. Right. Okay, what we did till now, that we are assigned 2 nodes from geometry, created beam and assigned it a property. Let's assign further specification. Okay, what is material? Material, if you want material like if steel grade is 275 Newton per mm square, or if we are using the 335 Newton per mm square, we can assign the material customizedly. Okay, you can edit some material, or you can create your own material which is available in the market, or you can assign the property, you can assign that property to the particular member, and you can analysis and design as well for it. For now we are going for supports. As you in your study, or you studied that every beam column has the supported. Okay, the one end is supported and the other is free, which is a cantilever. The both end is fixed. The one is simply support. There is a number of support like simply supported beam, simply supported supports, fixed supports, cantilever supports. Okay, so there is in our supports tab. This support tab include first option, there no support, the node. What we are going to do is we are providing supports to the node. We are going to tell the software that this node is fixed, or this node is free, or this node is hinged. And let's create our support. We are going to design it for a fixed support, the both end fixed support. Then you can see that fixed support tab resistance. As you know, any of direction, or there is no axial force. If you're going to use pin support, okay, you can see hinge support or simply support. There is what no uh, horizontal or vertical reaction is there, but there is a bending moment. Okay, for this and for now we are designing it with a fixed support. So I added a fixed support in the tab and selecting node. Okay, for this I am going to select tab. In selected, there is a numbers of cursor option, that a node cursor. If we want to select the node, we have to go with the node cursor. You can see I am selecting a whole element or geometry, but there is a only node is selected. If I take a beam cursor and I select, you can see that only beam is selected, no node is selected here. Okay, so with the node cursor, I selected both of the nodes and assign the selected node, select support to assign. Okay, there is the both the node is applied, that it is a fix. Okay, our geometry is now okay, and all we had in a problem is we specified. Remaining is our loading condition, that which type of load is there acting on a particular beam. For that, what we do, apply load in this beam, on this beam. Okay, so here I am going to the load tab. After support, there is a load tab. In load tab, you can see that there is a load envelope, definition, load detail, and here we are going with definition. What, as earlier I said, that in the StatPro we can design the any of structure. We can design the multi-story building, high-rise building, bridge structure, road structure, culvert, any of that. So in definition, what we do when we really practice the in a structural field, what we have a problem, that we have a longer calculations of the load calculation, that if we are designing a bridge, there is a vehicle code, that IRC, in which given that for the load what you have for the sorry, for this much of traffic, what the load you have to take. Okay, but you have to do, if you are going to do it manually, it's a too lengthy process and time consuming, and as you can see that there is a man error also in that type of calculation. And what StatPro offer is us that just we have to give them the parameters in which IRC gives that, and the code is already interact with this StatPro software, and the parameters is also given to the StatPro software. Just we have to give them parameter that yes, this much traffic is there. It also what it do that it extract the data from the code and take the calculation by itself. So we have to just define the what the vehicle load definition in our code. What I think you all had done the wind analysis in your subject. So let's see that a wind definition, what it gives. Let's edit one definition. See, add. Okay. What we manually calculated, we have to do is this just height and intensity. What we do the manual calculation of the height at which at height and intensity with the manual calculation, and we just put that height means at a 0 height there is a 0 intensity, at a 10-meter height there is a 1.2 kilonewton per meter square intensity. Okay, so by giving just this, we can easily apply that load to the particular whole structure. StatPro is automatically connected the effect of this load. Okay, same as seismic load definition. Post-over analysis that consume mean made. There is a chance of mean made error. Okay, for this much session, we are only going to see how we can apply dead load and live load on the particular beam or a particular structure. That's I add a preliminary load type. What's dead load? You see, you can see here that there is a all the type of load given, that dead load, live load, roof live load, wind load, seismic load, snow load, fuel load. All of them, these are here. That I'm selecting dead load, name it as a dead load. Okay, add. See, in dead load we are taking the self weight of the structure. Okay, so what we do in a manually, that we are taking the beam ISMB 600, we are founding in the IS code or steel table that what is the weight for ISMB 600. It is okay for where there is only one beam, that we are finding easily. What if our structure has a numbers of beam and every beam has a different property? We have to do manual calculation, like for this much length there is ISMB 600, for 600 1 meter length is this, for this much there is a 400 beam, there is a this, or we have to do manually bill of material calculation. Okay, in StatPro we are going to see how we can extract the bill of material from it. Okay, so what I do, dead load, describe what I am doing. I define dead load, and now I am describing which type of net and how much load is there. See, there is a self weight. Okay, self weight load. In which direction it is acting? In y direction. See, here y direction is upward, where the self weight is acting negative to gravity. Okay, sorry, positive to gravity. What it mean by it, that our y direction is up, so we have where the gravity force is acting in a minus y direction, so I provided -1 for y. It automatically calculate for, see, this is self weight, or here is question mark. Question mark is for you have not applied this load to any of the member. Now what we are doing, self weight -1 in y direction we are applying to the particular beam assigned to view. Okay, I'm applied my self weight to this one beam. What it means, if we are if I change the property to ISMB 400 to ISMB 600, it automatically calculate its weight by its property. If I am providing it's a concrete material with a 300 into 600 size, it automatically calculate the weight of the concrete member. Okay, we provided, and as a for the example, we are also going to do is provide and defined live load. Live load added, providing live load as a point load at the middle of the section. Yes, here you can see there is the multiple types of load we have to apply on the particular structure. Okay, there is a member on it, there is a plate on it. What a member load containing that uniform force means, if there is a beam and there is a UDL load, we can apply through it here. Uniform movement, if we have to provide the movement in some direction to the member, we can provide it from here. Concentrated force means a point load, so we have to provide this concentrated movement. At some point there is this much movement, we can define it with this linearly varying load. As you learned all this load, trapezoidal load, hydrostatic load. Where this hydrostatic load is at, it is act at a design of the water tank and the retaining wall, pre and post stresses wall, fix and okay. So we are defining concentrated force. As this force is this mix and how much load is there, Fi direct, mx, my and mz load for the sorry movement. Okay, but now we are providing the point load, okay, to the concentrated force of minus 10 kilonewton. Okay, see here it give the d1 distance or d2 distance. If you want that 2 meter from here, we have to write down the 2 meter in d1 2 meter, or what d2 is, if the load is not axial, it is uniaxial. So we have to uh, notate is this, but I want that the load at the middle of the point. So I give this value as 0, 0. Okay. In global y direction, right? I took minus 10 as it is a downward direction. Y is upward. If I took the plus 10, it is upward load. But I wrote that this is the minus 10. Okay. So added, deleted. Okay, assign to selected beam, assign, yes, yes, you can see here a load is applied on the particular beam. A 10 kilonewton load is applied. You can see the point load notation. Now what we can do, we can do analysis and design both the thing in this software. Before it, we have to define load combination. After load, what is there? There is a load combination. What we manually do is we are going to check the code and how much there is a load combination equation. The dead load plus live load is this much, 1.5 dead load is like this much. But this is the nominal. What if we are doing the design of multi-story building and we have to check for a earthquake load and the wind load? In manual calculation, it is not possible that we are checking with all that load combination there is for the wind load and earthquake load combined design. There is a more than the 50 plus load combination in that. That what StatPro is offer us that automatic combination. Okay, so I am going here that automatic combination, automatic load combination. See here, select load combination code. From which code we have to take the load combination? Here the American code, British code, and here is also our Indian standard code IS 456 and IS 8000. Okay, so from which table we have to, if we are going to design it with the working stress method, the load combination is different. For the plastic design, there is a load combination for difference. If we are going to design it with the uh, design for the steel structure, there is our code IS 8000 2017. So here also they mention the table number 4. If you want to check in table number 4, there is the load combination given. Okay, let's generate the load. You can see all the load combination are generated automatically. If I want someone to neglect, I can remove it, discard load combination or selected load combination. Okay, I added all the load combination for the our analysis. Yes, you see here all the loads combination are applied successfully. Okay, see first 1.5 dead load plus 1.5 live load, 1.2 dead load plus 1.5 live load. All the dead load and live load combination I applied automatically. Let we have to give command to analysis. Here in analysis tab, you can find pre-analysis command, post-analysis command, miscellaneous command, a type of analysis you want to do. You have to tell software that this or this much analysis I have to do with this structure particular. You can do multiple analysis also, or every type of analysis is available here. I am clicking on analysis, imperfection, perform buckling analysis, perform pushover analysis, change, generate floor spectrum, non-linear analysis, p delta analysis. All these analysis are available here. As what type of analysis we have need to design, we can do the same, or this is a print option. What do we mean by print option is, after the analysis, try to give us the report of the analysis. In report, what and which type of detail we have to see or we want, we have to define it here, that load data we want, static check we want, static load we want, mode shape we want, both or all. I selecting all. Okay, I give that command, that analysis, perform analysis, and do all checks. See, you can see here the perform analysis, print all. Okay, here I am going to run the analysis. It takes 2 to 3 seconds for analysis. What if we do manually? It to draw the shear force and bending moment calculation, or draw that diagram or see. Now what we guide the load, how it's displaced. Okay, you can see there is a fixed center. Okay, if you can say that in our manual calculation there is a notation that this much is the displacement, then how this software is also said that how maximum displacement done. Yes, here the maximum displacement is 0.281 for this much load. This is the, now what we have to see, that shear force diagram. Okay, here is your shear force diagram for the same load. Also, we want to see the value of it. We are going to annotate beam result, shear force maximum. Okay, at the midpoint. Okay. As you can see, we applied the point load. For at the support there is a straight line, and where there is a point load acting, there is a cross line, and here 5 kilonewton, 5 kilonewton. We are applied the 10 kilonewton load. So there is the two reaction upward and direct. There is a two reaction each of 5 kilonewton. Is it right? Okay. What we have to see, pending movement. Pending movement in which direction? In z direction. See, here is a pending movement diagram. All the in the manual calculation, we did this with the 10 to 15 minutes time, or in the software we did it in a 2 to 3 minutes or lesser than it. Okay, we can see that how much load acting. Okay, here you can see at the support there is a movement of 12.5 kilonewton into meter at center also, or here also. What if your professor change the loading? You have to do it twice. All the process is repeating, and you have to do repeatedly work. Or what if I am changing in the software is just deleting previous load, added new load as a member load, and I am applying this time that a uniform force. Uniform force selecting beam as yes. Okay, you can see a 10 kilonewton into meter square load is applied on our beam. Let's start our analysis. Okay, here run analysis, save. Display at this time. For that, there is a deflection curve is like this. Okay, we have to see it bending moment. There is a bending moment curve, you can see. Okay, fine. If you want to see shear force and bending moment, okay, if you want to see the value, go to the shear force. Okay, as you can see, 50 kilonewton, 50 kilonewton. The center there is a 0. Okay, fine. That what we do till now is the we provide that the created the geometry, provide support and applied load on it. After that, what we do analysis. After analysis, what we have to do is a design. For the design, there is a multiple code and multinational code are available in our StatPro. So in design tab, there is the lots of code available. You can see list of it: American code, Canadian code, British code, Indian code, Chinese code, Japanese code, New Zealand code. There is available. We can do analysis of with it. For now, we are going to design a steel structure. There is also command available for the different types of structure like steel structure design, concrete structure design, aluminum design, and timber design. For now, we are selecting steel structure. For steel structure, there is a code available: IS 800, IS 800 2007 limit state method. What we have to do, if we have to do with a working stress, there is an option with a working stress design also. So I'm going to select with a limit state method. Going to apply and input that code. You have to check that this much beam is passed on this much load. Okay, I am at that option. Also member takeoff. What it mean by member takeoff? That how much member length and the weight is used in the particular structure. So assigning check code to the our beam, assigning takeoff to the our beam. Okay, now run the analysis, run my design, and let's check it. Then there is the option view output file, go to post processing mode, and stay in modeling. What is view output file? Output of analysis file, go to post processing mode. As we are earlier see that shear force and bending moment. For that, for view output file, this time we are going to see view output file. Okay. In steel design, we are going see in steel design member number one. The member section is the section is passed to taking load and load applied. Understand? Taking the load. If a member take the load of 1 kilonewton and we applied the load of 1 kilonewton, it means its ratio is 1. But here the ratio is 0.66, 0.611. What it means? There is a 40% more capacity of this section to take the critical load case is a 1 and location as 0. The member is passed. For the every member we design, this is the so that member is passed or member is failed. If the member is failed, it shows in which uh, criteria is failed. You can see here critical condition slenderness in a tension. Okay, for steel takeoff, what list is here? That ISMB 600 length is 10 meter, its weight is 11.830. So we can also calculate the bill of material from here. Okay, now coming to this, we have okay, going to our PPT. Okay, and lastly, I conclude with it that advantages of StatPro from what we learned in this session, that we can do any type of structure design in the StatPro. Okay, with there is a numbers of code available, numbers of criteria available. We can design in sitting India with all over Indian or American or British code, Chinese code. We can use any of code. Already all the codes are there in on parameters is also set it there. International codes also available. The one thing that software offers you, that there is lots of quality and accuracy in that particular software. Report and documentation in the steel structure design or concrete structure design. In designing part, documentation and report is a must require after designing, that you have to submit someone the documentation and report. If you are doing manually, it is too lengthy process. And for beautifying that a report, this software give you a automated generated report which you can customize that report with the photos you want, that in and all that detail what you want you can add it in that particular documentation. As a lack of time we are not covered that option, reporting and documenting. Or finally I conclude with Statpro is widely used by most of organizations in India and in all over of world. Unfortunately, well-skilled Statpro engineers are very hard to find, and I request all of you to take your eyes on this software and try to learn it. It will help you in future. Okay, the student which are interested in a structural design or who are planning to do structural engineering, I request all of them that please keep your eyes on this software. There is lots of video available on YouTube also, or Bentley also uh, time to time upload that video and do seminar on it. Also our college Parul University has a program, part-time program of learning Statpro TTAPS. Okay, if we believe in prediction of the industry expert, then those students who will be getting trained on Statpro in the current and upcoming 2 years will have a bright and successful career ahead of the real estate and the construction domain. I hope by attending this training, Statpro, we were able to learn the various features of Statpro, which will be very helpful you in nearby future. I hope my words will be helpful to you in the future. I tried my best to convey the knowledge, my knowledge of Statpro. Okay, thank you, madam. Madam, you are not audible.